Hi, we're Group 8, and our project is noise-canceling headphones. My name's Jillian.
I'm Megan.
I'm Stephanie.
And I'm Daniel.
And our advisor is Mahdi.
The purpose of our headphones are to be worn in workshops that have consistent loud noises, and we want to extend the longevity of a person's hearing. Our design features 4 omnidirectional microphones that detect noise and process signals in front and behind of the user so they can hear alarms and instructions, but they cancel the noise on either side of the user to protect them from that.
Some engineering constraints that we're taking into account is obviously to block the noise around them, making sure the headphones are rugged for machine shops, used in different environments, and adjustable for different head sizes.
So 2 microphones will be placed on each side. The length of the microphone is equal to 4.72 millimeters, so the distance between them will be equal to 9.44 millimeters. So if the pressure of the first microphone is equal to the second microphone, then there's not going to be any gradient between them, and the user will not be able to hear that signal. So this is a block diagram of the schematic. So we'll be using a 3.7 volt battery. And with that, we're going to have to use a 3.3 voltage regulator to make sure that the microcontroller gets a constant 3.3 volts to operate. So to control the volume, we're going to be using a potentiometer. And here you can see here that the signal gets stop turning. So a second order low pass filter was designed using the Laplace transform. The cutoff frequency was set to 15 kilohertz and a 1 kilo ohm resistor was picked, resulting in a 0.33 microfarad capacitor. The circuit was simulated using LT Spice, and as you can see, as the frequency increases, the noise from the electronic noise from the microphone decreases. The frequencies were tested on the physical circuit from 1 kilohertz to 15 kilohertz, and the distortion in the signal, the output signal, is because of the LM324 op-amp that was used.
For the charging portion of the headphones, we'll be using various modules to control the charging as well as to monitor the charging of the battery. With the module, we'll be able to inform the user of the battery's percentage as well as the battery life and when the headphones will need to be charged. Here you can see the code that was used to test the modules, and for the output we're able to find the voltage of the battery's percentage, as well as the charging rates per hour, and with that we're able to calculate the life of the battery.
So this is the first headband assembly. It'll be held, the different pieces will be held together with screws. This is what it'll look like when the person is wearing it. In the middle, those holes are for an adjustable headband piece, and then the purple tracks are to guide the adjustable part and the wires through the headphone, or the headband. This is the first headphone assembly. So the gray is just a foam padding that will cover the ear. The dark purple there is a mock speaker. And then the blue is going to hold everything together, and that'll again be held down by screws. The green piece holds the microphone or the speaker in place, and it has holes for the wiring of the speaker to come out. And then between the green and the blue is where all the electrical components will go.
Here we have another prototype. So you have the headpiece, and it's currently connected to the earpiece, and the purple represents some foam that we'll use. Currently, we're thinking that we can connect the headband part to the earpiece part with extrusions and possibly soldering them together to make it make the plastics mold and conform together. So here we have what the headphone looks like, headpiece looks like again. These holes are for the speaker. We have left and right. And again, this is the inner part of the earpiece. So the green cap is going to go on top of where the speaker will be. and then the battery will lay on top of this cap. And then in the other earpiece, you'll have the microcontroller and other electronic components. Also, everything will be screwed together, and also providing the user with an on and off switch, volume, button changes, and a USB port to charge. For next semester, as MEs, we will continue working on the SolidWorks and working to make the headphones adjustable so they are very user-friendly.
As a CE, I'll be designing and printing a PCB board for both the microphones and the filter and amplification circuits. With these PCB boards, we'll most likely have either surface mount or through-hole soldering for the components. And last thing for CEs, we'll be working on the noise cancellation calculation in the microcontroller's code.
As the EE for next semester, I will be helping the CE design the PCB board for the microphone. I will also be debugging the circuit so that it cuts off at the frequency 15 kilohertz. And once the microcontroller code is finished, we will be testing the circuit with the microcontroller to make sure we can cancel out signals.
That is everything. Thank you.
Bye.